Take an example. Fx is equal to plus 1 when x belongs to rational numbers and minus 1 when x belongs to irrational numbers. You can also this write it as r minus r from which rational numbers have been removed. R minus q. Wait a minute. Let me write it properly. Wait. So r minus q. From where? From the real numbers or from where? You write like this or you write like this. This is the way. Now gx is a function which is 1 at x belongs to q and is 1 is minus 1 when x belongs to q and plus 1 when x belongs to qc. Qc, you know what it is. From real, you have removed rationals. Now see, f and g are not continuous. F and g are not continuous. Not continuous. Sit, yes, you write full. Now if I take f of g of x, let's take if x belongs to q. For x belonging to q, I am taking it. F of g. So this becomes f of gx. Now x is belonging to q. See the g. X is belonging to q. It will be minus 1. F of minus 1. F of minus 1. Minus 1 is a rational number. So you'll get, for rational number, you will have to take this. So this will become 1. Take GOF. Sorry, for x belonging to irrational number. Now you take x belonging to irrationals, not GOF. Wait a minute. GOF I will give you for a homework. X. Now this x is belonging to irrationals. Now f g of x. Now this x is belonging to irrational means, just a minute, let me drop this text. Now x is belonging first here. So it will become 1. F of 1 it is. Now 1 is rational. 1 is rational again. So it belongs to rational. So it will be 1. So you see whether I come from the rational part or I come from the real part. Therefore, the FOG at x equal to 1, FOG of x for on any x, under under this condition, FOG of x is continuous for all x. Wait a minute, for all x. Let me write that for all x belonging to real. So it is continuous, but individually they are not continuous. This was the point I wanted to emphasize on. Now, the next point. Let us take one function like this. Question. fx equal to mod 1 minus x mod plus mod x whole mod. Let me take this whole mod. Let me take this as whole mod. This whole mod. Now it's okay. Now this part is C. Let's write it as two different functions. fx is equal to hx, where hx plus gx. Wait, and on this, and let me write yes, and this as wait, let me write this as yes. Let me take it in this manner. It will be easier if I take it in this manner. If I take it in this manner, I take hx, I take hx, I take hx as 1 minus x mod plus, no, sorry, and gx, wait, gx as mod x, right? Now this is a mod function. See the graph. This is same as writing x minus x mod, x minus 1 mod. So this graph is somewhat like this. This is continuous. So hx is continuous. What is the graph of this function? This is like this at 0. This is at 1. This is at 0. Gx is also continuous. So let's write h is continuous. H and g are continuous. So hx plus gx is continuous. This is very clear. This is very much clear. Then you will see one more very important result here. And then I'll give you the result only. Now this is continuous. This is continuous. So the sum of two continuous function is again continuous. Now let's see a function, say uh, this let us call this let us call this let us call this cx. Cx is hx plus gx, that is nothing but 1 1 minus mod x plus mod x, no problem, they're both continuous. Now let us define a function ex as mod x. See, I'm defining ex as a mod x. Now what I do is that, see, I told you one thing. I told you one thing that if f and g are continuous, then if I write e of cx like fog, I've written e of cx. That means e of cx. What is c? What is cx? Wait a minute. Let me write it properly. Wait. E of cx. Cx. What is cx? Cx is this whole thing. So e of mod mod 1 plus x plus mod x. Now, what is ex? Mod x. Whatever you write here, that has to be written here. Now, you have written this in place of x. So, this will give me mod of 1 minus x mod plus mod x. Again, FOG is continuous. I told you if f is continuous, g is continuous, then FOG is continuous. The thing that I told you earlier. So, this thing has to be kept in mind. Now, let me tell you a very important result. I'll just tell you the result. If say the result is result if f is continuous, CTS, I'll write CTS, you people will write the complete word, at x equal to a, then mod of f, that's what I've done here. Mod of f is also continuous. You can do it this way also. Wait, is also continuous. Let's see why. Let's see why. I said fx is continuous. That means by the classical definition, you remember this. Fx is fx minus fa. This actually means what? Limit x tending to a, fx equal to fa. I'm telling you in this rough actually what it means. This also means, this by the classical definition, this I'm writing in the rough so that you understand what I'm doing. Fa minus L is less than epsilon. I hope you remember this classical definition. Whenever x minus a is formal definition, classical definition, what you want, less than delta. So fx is continuous at a, no problem. I can write this using this, less than epsilon, whenever x minus a is less than delta, right? Now the point is, this is the idea basically. Now what I'll do is that I have to find the mod of f. This is, I will take the complete mod now on both sides. Wait, I'll tell you what. Now I have to show this. Mod of fx minus fa mod is also less than epsilon. I have to show this. So now this is this. That means, wait a minute, did I write it? Did I write it correctly? Now this means this is less than mod of fx minus fa, and fx minus fa is what? Less than epsilon because it is continuous. So this means a mod function. So mod of fx minus f of a whole mod is less than epsilon because of this result. Now, how did you get this result? I'll tell you. Wait, look here. There are certain very, very important results I'm writing down. No, I'll not rub. I'll rub this side. I'll write the results straight away. The results. So important are these. First result. Now, result number one. Result one. Mod x minus mod plus mod y is less than equal to mod x plus mod y. First result. Second result, mod x minus y can be written as mod bracket plus minus y, and this is equal to this is less than equal to, sorry, this is less than equal to, using this result, this is less than equal to mod x plus inside mod y, and mod minus y is same as mod y. So you can say this is equal to mod x plus mod y. That is, mod x minus y is less than equal to mod x plus mod y finally. Wait a minute, let me write it clearly. This is mod y. Okay. Now the third part, which I have used here, which I have used here, that result I'm telling you. See, that result is, wait a minute. Yes, wait a minute here. The third result is, mod of mod x minus mod of y is always less than mod of x minus y. Keep this thing in your mind. This is the result I've used. I have used this as fx, this as fa, then this is fx fa, and this is less than epsilon. So this is what I've been done here using this result. Now let us do one or two questions with formal definitions. Let us do one or two questions with formal definitions. Yes, let me take this question. Using formal definition. Formal definition. Let me write down. Show that. Show that. Show that. Show that. Show that fx equal to x square minus 4, x minus 2 for x not equal to 2, and as 4 for x equal to 2 is continuous CTS at x equal to 2. At x equal to 2. So I'll use the formal definition fx minus f of a is less than epsilon whenever x minus a is less than delta. Given epsilon, I have to find delta. Given epsilon, I have to find delta. So the point is, here we will write, here fx is x square minus 4 upon x minus 2 minus, what is fa? At a equal to 2, fx is 4. Minus 4 is less than epsilon whenever x minus 2 is less than delta. Now we will have to do the computation here. Computation here is exactly like the limit one. You write this as x minus 2 and x plus 2, a plus b and a minus b. And then this is x minus 2 minus 4. Cancel this 2. You will get x plus 2 minus 4. And this will be x minus 2. X minus 2, that is x minus 2 is this less than epsilon. That means taking delta equal to, see, I'm getting x minus 2 here, less than epsilon, I'm getting x minus 2 here. So delta should be equal to epsilon. Delta equal to epsilon gives this fx minus, what is my fa here? Fa is my 4 less than epsilon whenever x minus 2 is less than delta, is less than delta equal to epsilon. Let me write delta equal to epsilon here. So now this is one such question. The other such question we will be doing. Here you see, yes, here I will show you. See, question, a good question. Fx is 1 upon x is continuous in 0 and I told you it is not continuous at 0 and 1, but it is continuous inside. So I'm going to use the formal definition. Fx minus, let's say, fy. Now I'll take this definition, is less than epsilon whenever, because whenever I can't put the limit 0, I can't put the limit 1. मैं 0 भी नहीं put कर सकता, मैं 1 भी नहीं put कर सकता, मैंने इसलिए y लिया है, f0 f1 नहीं लिया है. Whenever x minus y is less than delta. So write 1 upon x minus 1 upon y. Just write it, solve it. Now try to solve this. This is nothing but y minus x upon xy. This can be written as x minus y upon xy. So this is, see one thing. See one thing. This, you can write this as less than, see, you can use this concept mod x y xy is equal to mod x mod y, which is greater than mod x. No problem, you can write this concept. You have 2 3 6 mod 2 mod 3, that is 6 is greater than mod 2, that is 2. Telling you 2.3 multiply, this is 6 actually, this is equal to mod 2 mod 3, and this is greater than mod 2, isn't it? This is the idea I'm using. I can write this way, no problem. So if I write this, now see what I'm doing. Now see what I'm doing. Now see what I'm doing. Now I'm taking it little down. Yes. So I can say mod 6 is greater than mod 2. I can say 1 upon mod 2 is greater than 1 upon mod 6. If you take the reciprocal, inequality will change. Let me write it here this way. Otherwise, you people will get confused. Wait. Let me write it 6 here and 2 here. And let me, wait a minute, let me write it this way. So 1 upon 6 is similarly mod xy. So you see, here I am doing it. Mod x mod y is greater than mod x. So 1 upon mod xy is less than 1 upon mod x. You can see this using this concept, the concept that I've used here. Now multiply both sides by mod x minus y. So what you get? See, what you get. What you get. I'm doing it here since before I write here something, I'm doing everything here since. So mod x minus y mod xy is less than mod x minus y mod x, no problem. This, so I can say this is less than, let me write let me write less than, so less than mod x minus y mod x, and this should be less than epsilon. This should be less than epsilon. So that means this all is in sense. You should write this. This you should write. This I explained you. मैंने ये explain किया, ये तुमको लिखना है. और यहाँ से मैंने ये लिखना है, ये concept भी लिखना है. एक मिनट. Let me rub this. You should write this concept also. This is the point, which is very important. This, and this. This is the point is important. Now this is less than epsilon. Let me rub it. Let me write it clearly. This is less than epsilon. So after this, writing all this, then you write this mod x minus y is less than x epsilon. Mod x minus y is less epsilon. Remember, it is dependent on x, so it is continuous. So come here to this point. So what did I get? Mod fx minus mod x is less than this. I got this is I got so let me write here. So this is less. Therefore, compare this with this one. Wait, compare this one with this one, compare it, this one you compare with this one, इसकी तुलना इससे करो, तो डेल्टा क्या आ रहा है? x epsilon आ रहा है. Delta is coming out to be x epsilon. If you compare this one and this one, here this is like behaving like delta, so delta is equal to x epsilon. So let's write it down. Let's write it down. Taking or choosing what you want to write. Delta equal to x epsilon. This 1 upon x minus 1 upon y is less than epsilon whenever x minus y is less than delta.